Now, this is going to be a short video, a continuation of section 5.2. If you see, what we did in the last video is to look at the relationship between input and output of the operational amplifier. They like to call it as voltage transfer curve. Okay, we saw that there are two regions of saturation and one region of linear operation. We like to keep it in linear operation as much as possible. Now we are going to look at an interesting topic called ideal op-amp assumptions. Okay, the textbook likes to call it by a different name. The textbook likes to call it as voltage and current constraints. What it really means is, I like to think of them as two rules. Okay, two rules. That's all you have to follow when you are analyzing op-amp circuits in open loop configuration, feedback in any op-amp circuit. When you are ready to solve problems, just apply these two rules. Okay, rule 1. Okay, and because you want to keep your op-amp in linear region, Vp is always going to be Vn. Magically, Vp will equal Vn as long as you are in linear region. Okay, this rule is called a virtual short. Okay, this rule is called a virtual short. Now, the second rule, that's it. The second rule is IP equals to In equals to 0. I'll show you what it means in the symbol circuit diagram, but this is called R input. Input impedance looking into the op-amp is infinity. Okay, so let me show you what these rules mean. Here is your op-amp, right? There are the two terminals. There is your negative terminal, Vn, okay, and there is your positive terminal, Vp, and of course here is your output. And I'm not going to explicitly show the power supplies, but what the rule number 1 says is, maybe I should put them all in black. Okay, let me put them all in black. And rule number 1 says, whatever value you apply here, that magically shows up here as well. Okay, and this is coming from the fact really because the open loop gain is a really large number. Ideally, open loop gain is infinity. Okay, when your open loop gain is really large and you make the op-amp operate in linear region, what is going to happen is these two terminals are going to behave, okay, as if they're shorted together. They're not really shorted together. However, they behave as if they are shorted, hence the name virtual short. That's rule number 1. Okay, now rule number 2 is, so rule number 1 again is Vp is the same as Vn in linear region of operation. Now, rule number 2 says this, okay? The amount of current going into the negative terminal of an op-amp and the amount of current going into the positive terminal of an op-amp, they're equal. Not only are they equal, they're actually zero. Okay? There is no current going into the input terminals of the op-amp. Okay? That's the idea. IP is the same as IN is the same as 0. There is no current flowing into. How easy can it get? As a matter of fact, these two rules will simplify your analysis of the operational amplifier significantly. Okay, so these rules, how often do you come across? Here is the idea. How often do you come across rules in life that are actually helpful? Well, these rules are helpful for you. Okay, so the rule number 1 is that the positive terminal and the negative terminal of the op-amp, both of them equal each other. They behave as if there is a short between them. Okay, now the second rule is the amount of current going into the terminals is 0. That's it. These two rules will save a lot of time and effort for you, and then you're going to enjoy the upcoming analysis of operational amplifier.